Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're going to be taking a look at and hopefully repairing one of my favorite 8-bit game consoles of all time, the Famicom, or also known as the Nintendo Entertainment System here in the US. This Japanese domestic market game console was really the grandfather of all the Nintendos that we know in the rest of the world, and it looks a little bit different with the color scheme and even the built-in controllers with cables, but it really is just a Nintendo Entertainment System. You would have recently seen this video on a Super Mini Mail Call episode on the second channel, where a viewer sent this in and indicated that an AV mod had gone wrong, which seemed to have rendered this console unplayable. And then on the main channel, I recently did a Nintendo repair-a-thon where I tried to repair 4 consoles, including this one. And at the end of the video, when I got to trying to repair this thing, well, it seemed like there was a bit more damage than I expected on this, so I left it for a future video. And that's what we're at now, where I'm going to try to get this thing working again, but I also want to actually AV mod this, because one of the limitations with these original consoles is they only have an RF output that really works with Japanese television standards and not necessarily in North America. So without further ado, let's get right to it. So in the NES Repair-a-thon, when I dug into this, we saw that it had a bunch of capacitors and wires installed on the board, specifically because it was trying to add an audio-video output instead of just using the RF. This module takes the DC input, the unregulated DC input, regulates it to 5 volts, sends that to the logic circuits, which then send the audio and video signals back to this board where the RF modulator is. And there's a channel select switch, I think, or one of these switches selects the channel, and the other one, it turns the external switch on the back of your TV between TV and game. I think it sends a little bit of voltage over the RF connection to the switch, so it can auto switch, so having to manually switch it. In fact, at least in North America and probably the rest of the world, the front loader NES did that automatically. So when the console was turned on, it would automatically switch what was behind your TV between game and television, which was nice. That was a big improvement from the way all the 8-bit home computers worked, where you had a manual switch, and not just home computers, actually, like the Atari 2600 and other game consoles. You had to manually switch between TV and game. Typically in North America, you use channel 3 or 4, or sometimes 2 or 3 in the case of Atari, for the RF output from your game console, but having to go behind the television to flip that switch was still a little bit of an annoyance, especially if your television was mounted inside a console. So with the front loader NESs, that was just handled automatically. You just set your TV to channel 3 or channel 4, turn on the console, and boom, you'd be up and playing games. And the RF output quality was also very good on those Nintendos. For a long time, myself and all my friends who had Nintendos, we all had it hooked up through RF, and the image quality was always excellent. But with the original Famicom, looks like that automatic switching was not automatic, and it was this switch there, and you can see it says TV games. You just have to switch this on the back of your console, which, you know what, is still better than going behind the television. So thumbs up, Nintendo. Anyhow, what I did is I removed those extra bodges. There were some capacitors and some flying leads on the back side of the board, and then when we flipped this over, there were some more mods done on the top side, including the removal of this transistor. And from my understanding, this takes the video output from the PPU, the picture processing unit, and buffers it and then sends it to the RF modulator, which then probably has another transistor in there, and whatever, it turns it into an RF signal. So for the typical homebrew AV mod that you would do to one of these to add the audio video output, you would reuse this transistor, connect it to the PPU's video output with some additional resistors, capacitors, and things like that, and then that would allow you just to get the video right out of this. And taking this off would disable the RF output, but that's fine, because Jan was in the Netherlands, and there's no way the Jan would have been able to use this Japanese RF signal anyways. I think in North America, you can use this on cable TV channel 94 or something like that. It happens to coincide with one of the 2 RF channels used in Japan. But one of the big problems that I noticed while working on this after I reinstalled this transistor is that pin 21 of the PPU was missing entirely. It had been broken off, and that is the video output pin for the PPU. So I used a little Dremel to cut a hole in the body of the IC, and then I used a little offcut there to try to reconnect the output of the PPU to the base of this transistor. I actually don't know if that worked, because once I powered this up, I didn't really get any kind of active video signal coming out of this pin. So then I moved over to the clock circuit, which happens to be pin 18 on the PPU and one of the CPU pins as well. And the clock circuit's very simple on the Nintendo, 21.47727 megahertz. You can divide that by 6 to get the NTSC color carrier, which is why it's using that specific frequency. This is a little adjustment to adjust the crystal oscillator just so you can get it dialed in perfect. Well, using the oscilloscope, I looked at pin 18 on the PPU. there was no clock. There was absolutely no clock at all. And without a clock, Nintendo's not going to do anything at all, including output any kind of video signal. There won't be any kind of sync pulses, nothing. So the very first thing I need to do to even try to get this thing working, to see if that video output's working on that chip that I drilled into, I need to get the clock circuit working. So since discovering in that repairathon that the clock was the problem on here, at least the initial problem, I started thinking about ways I could go about fixing this. We could obviously just replace all the components that involve the clock circuit, but you know me, I like to try to figure out what exactly is wrong. And I do know one thing, that the crystal oscillators that are on these boards, the little silver can that has the actual crystal inside, I really don't find that those go bad too often. They're a very, very reliable part, and I think physical trauma is one way they can be damaged. But ultimately, I'm gonna err on the side that there's some other component in the clock circuit that's actually causing the clock not to work, and it's not the crystal oscillator. One thing that's really key about the clock circuit on Nintendo's, and we learned this in the repairathon, is that even when it's just slightly off, it causes issues. The crystal oscillator on one of the broken Nintendos I worked on was like 21.47 something megahertz. It just wasn't close enough, and that caused the entire color carrier to be so far off that you weren't getting proper color decoding on any of the images. What that means is if I'm going to replace the crystal oscillator on this board, I have to replace it with one that's exactly the same as the one that's on here. Now, luckily, I happen to have spare NES boards, including one that has the whole RF modulator ripped off of it, so I can easily harvest parts off that to fix up this console. But I think the first thing to do is to check the components around the crystal oscillator to see if all of them look good. Almost certainly one or both of these transistors, since they're in proximity to the crystal, are related to this circuit. These types of 2-pin crystal oscillator packages generally cannot drive the crystal inputs on various chips together. If it was just going directly into, say, the CPU or the PPU, I could believe it. But because this is going to be going to both of these, there's going to have to be a buffer circuit, and that's going to be what one or both of these transistors is for. Not to mention these small capacitors and this adjustable one we already know is for adjusting the crystal oscillator, fine-tuning it. So let's try to investigate how this works. So a quick Google for the original Famicom schematics reveals the actual clock circuit. It's not the highest quality scan, but you know what? It's going to be good enough for our purposes. There's the 2-pin crystal oscillator, 21.47727 megahertz. This component with the line through it is the 30 picofarad adjustable capacitor, and it has in parallel an 18 picofarad capacitor. I removed that 18 picofarad capacitor on the broken front loader to get the clock circuit to dial into the correct frequency, the 21.47727, because with that installed, it was too slow. I'm no expert in the way these analog circuits work, but I could figure out by just touching the back of the board with my finger that adding additional capacitance in line with the crystal actually slows it down. So if crystal oscillator is running too slow, like in the case of that front loader, then removing the 18P capacitor did the trick. But if it's going to be running too fast and you can't dial it in to slow it down, then you could add additional capacitance on C22. So instead of 18, maybe add a 30 picofarad, and then that maybe will slow it down enough to get back in tolerance. But when we take a look at the output of the crystal oscillator, it seems to set up maybe like a resonance circuit or something using this Q2 transistor. So one side of the crystal goes directly to the base of Q2, which when turning on should connect this 5-volt rail, which is going through a 1.2K ohm resistor down to ground. So that should bring the entire signal down to ground, and then when this is turned off, it should go back up to 5 volts, and then that'll allow this oscillation to happen. And you can see that the output of this goes back into the crystal as well. So I think it kind of resonates the crystal, and that's what gets it kind of oscillating or vibrating at the exact frequency, and this here is generating the actual clock signal. So we really need to check what's happening on this transistor. If this transistor is bad or shorted, then right away this whole clock circuit's not going to work. Now it looks like the output of this makes its way through a small little coupling capacitor to pin 18 on the PPU. That's the clock input. Pretty sure that's what I checked in the last video, and I saw absolutely nothing there. And then in addition, this goes through another buffer transistor, Q3, so that second one that we saw that was over there by the crystal oscillator, and that seems to go to the clock input on the CPU. So this transistor would certainly be something to check if we had no clock on the CPU, but we had a clock on the PPU. Although, if this transistor was shorted, like the base was shorted to the collector, that would just short it to 5 volts directly, then if we take a look at the clock signal on anywhere, including on the actual crystal itself, because they all are connected together, we would see it up at 5 volts. So if this transistor was shorted, that would also cause the whole circuit not to work. So both of these need to be working properly and not shorted for this crystal oscillator to work at all. And if this one was just open, for instance, like it was bad but open, then we would have no clock on the CPU, but we could have a clock on the PPU. And if this one were just open or not working all the time, then that would just result in the entire clock circuit also just looking like it was up at 5 volts all the time, since this 1.2K resistor would pull it up to 5 volts. If this transistor Q2 were shorted from base to emitter, then that would be connecting this side of the oscillator to ground. And then ground would go through this 220K resistor, and then it would have to be fighting against this 1.2K to 5 volts. So that means it would just pull it down slightly off of 5 volts, and the whole thing would just be sitting there doing nothing as well. So really, for the clock circuit to be completely dead, we have to look at these 3 components, Q2, Q3, and the crystal oscillator itself. But we're going to start with the 2 transistors. And these are our 2 transistors, and I'm pretty sure I have to flip them back over because I don't remember which one was the base. I assume it's the same as this one over here. So emitter, collector, base, and the notch is there. So that means that base is the pin towards the top of the board or towards the RF modulator. So that would be these top pins. So I put the multimeter in diode mode, and that one is fine, 0.7 volt diode drop, totally normal. And we have 0.7 volts there as well. And these other ones, flipping the leads around, everything looks fine. Ultimately, what you're looking for is a short. And if you short these together, the multimeter will read something like it is there, all zeros or almost all zeros. So everything looks good on that transistor. Let's try this one here. That's fine. That's fine. That doesn't show anything at all, which is good. Regular diode drop there. Regular diode drop. Everything looks completely fine with these transistors. Now we can see that there's lots of rework that's been done here. This was me reinstalling the transistor and trying to get that PPU pin reconnected. Just double checking just to see if any of this rework didn't result in any kind of short between traces and ground planes, things like that. Okay, I don't see anything initially using the magnifier loop there. Let's get this thing powered up and let's poke around and look for that clock circuit. I just want to see on the back side of the board what it's really doing. A couple things to keep in mind. The Famicom runs on DC and center negative DC, which is kind of typical for Japanese stuff. All the front loader NESs, unlike this, have a bridge rectifier, so they run on AC or DC, and the polarity doesn't even matter. So I have the leads from my bench power supply reversed. I'm going to feed 7 volts, 400 milliamps into this. Let's turn it on. Okay, we're using 283 milliamps right now. Checking the output of the power board back on the main board, we're at 5.1 volts. So everything is looking good from a regulation standpoint. Let's see if we can see that clock signal. So this IC is the PPU because there's the video output. Video output's pin 21, so that's pin 20. Pin 18 is the clock output, and we're at 650 millivolts. So it is just kind of sitting there and doing nothing. We can poke around on these transistors here, which we know aren't shorted, and we should be seeing kind of the same thing. That's just 50 millivolts, 650 there, 650 there. This is obviously, here's connected to 5 volts directly, and 400 millivolts there. So no activity at all on the transistors. Now I happen to know that these 2 pins are the actual crystal itself, the little silver package, and we should be seeing basically the same thing, just about nothing on both pins. Yeah, 250 millivolts and 700 millivolts there. So just to reiterate again, without a clock signal, you're not going to have any activity on the entire system, especially on the video chip. The video chip requires that clock signal to even output sync and pulses and whatever else. I think on the Nintendo, the PPU, if it has a clock signal going into it, even if the CPU is not initializing, it will still always output a video signal. You'll see those sync pulses and the color burst and whatnot. And of course, we're not getting any of that. I don't even need to go check it because we're not getting any clock signal or clock activity, period. So got to fix this clock circuit. Now look at the top side of the board, our 30P adjustable cap. Looks like the 2 joints on that component have been reworked. Kind of makes me think that someone knew there was a clock issue on this board and, I don't know, thought to try to reflow that component. But you can see right here that the crystal itself has never been reworked. And in fact, none of the other components in this area look to have been reworked except for the little 30 picofarad adjustable cap. So we know from the schematics, one side of the crystal oscillator goes directly to the 30 picofarad cap and another little cap that's in parallel, and the other side goes down to the other side of the clock circuit. So I'm just trying to figure out which of these sides is connected to the adjustable capacitor. There we go. Okay, that side is what's connected directly to the adjustable cap, which when we look at the schematics again, it looks like this point here is connected to there. That's what we were just probing with the multimeter. The reason why I'm looking into this is I think I'm going to remove the crystal oscillator from the board, and I'm going to try to inject the clock directly into this board, the 21.47727 megahertz, and you would want to do that injection on this side because we know that's what's going to the base of Q2, which is going to generate the clock signal. There we go, just like that. That part fell out. And there's our potentially suspect crystal oscillator. Now, from my recollection, this thing actually has a frequency generator. Where is that? I've never actually tried it before. I think it's under more apps. Gen. Looks like it can go as a sine wave up to 344 kilohertz. I'm assuming this can't go any higher. Oh, this can as a square wave. How high can we go? Looks like we can only go up to 500 kilohertz there. Okay, so totally useless as a frequency generator. That's kind of why I never really tried to use this for that. I think the output is one of these here. So I'm going to be using this inexpensive 30 megahertz generator, UTG 932. So 21.4772700 megahertz, very accurate. Probably turn down the amplitude because I think the original clock circuit runs more like at 2.7 volts peak to peak or so. And I'm going to put the offset down to 1.55 volts peak to peak. So that's just going to keep the sine wave above the ground plane. And if we turn this on, now it's going to be outputting out of the output here, that exact frequency, which we need to run this Nintendo. All right, so the probing around told us the output of the crystal oscillator goes to this side of that adjustable capacitor. So I'm just going to clip onto that same exact spot, and we need to clip on the ground lead as well. And the scope is clipped on right there. So I'm going to turn on the power to the Nintendo. There's not any clock signal right now. And let's see what we see. So with the power onto the Nintendo, we're getting 200 milliamps. Let's turn on the crystal output. It's not really doing anything. Wait a second. There we go. I had the time base set incorrectly on my scope the whole time. Well, that wasn't very helpful because I don't know what I had it like. Was it milliseconds or something like that? So we weren't able to see any kind of a clock signal. Let's check the clock signal that goes into the PPU. That looks terrible. It's there, but it certainly doesn't look good. Turning up the amplitude up to, now it's at 4.7 volts peak to peak. It doesn't really look any better. So that's the input to the 30 picofarad adjustable cap. You can see that that sine wave is a lot bigger now. If we look at the other side of the adjustable 30 picofarad cap, we get that. That doesn't seem quite right. And probing around on the transistors, that's exactly what we see, kind of the same thing. Not a whole lot of anything. So I'm really not convinced that this crystal I took off the board is bad. I still think we have something else going on this board here. Now, I'm not really sure if feeding this clock signal in like I'm doing here is an appropriate thing to do. Maybe it's not, and that's why it's not working, but just seems odd to me. So maybe what I should do is I'll move the connection of the output of the oscillator from the left side of the caps to the right side. So it'll basically feed directly into the base of Q2. Let's see if that makes any difference at all. So there we go. I moved to the other side of the cap. Let's turn on the power to the console. Looking at pin 18 on the PPU. We don't have a clock, but this is off right now. Let's turn it on. Nope. That still is not going to be an appropriate clock for that chip. It needs something better than that. Now, with the crystal oscillator removed from the board, it really takes these capacitors completely out of play. They're not doing anything anymore since that crystal is just missing. So you can just imagine all of this stuff is just gone. And I'm feeding the signal in right there. That should be working on the base of this transistor. It just doesn't really look like anything is coming out of it at all. Like it's just not working correctly. Now I can hear it now. There's probably people who are angrily commenting or screaming at their screen that I'm doing this wrong, but I really just don't know much about the way this analog magical resonance clock stuff works. So I feel like I'm just stumbling around in the dark, just sort of making guesses about how these circuits actually work. I think what I'm going to try next is, without removing any other components on the board, I'm just going to try to feed this signal from my signal generator right into this point and see if that generates the clock properly, just sort of bypassing Q2 entirely. And with Q2, which I happen to know is the transistor closest to the large 40-pin dip, the emitter is what's connected to the ground plane. So you can tell exactly which pin is the emitter, which is this one right here on the ground plane. And this is going to be the base, and that's going to be the collector. That's where we're going to feed the signal, because I know that Q2 feeds from its collector directly into the base of Q3, and this transistor is used to generate the clock signal that goes to the CPU. So let me clip right on there, and let's see how it goes. All right, so we're on the clock pin on the PPU. We're getting 1.6 volts. I do not have the signal generator turned on, so let me turn it on. Okay, we're getting a clock signal, but it doesn't look very good. I should have realized at the time that this wouldn't work because I was injecting a signal that was fighting against the output of the transistor. The transistor was still in place and it was still trying to drive that line to whatever voltage it was trying to drive it to. So that clearly wasn't going to work just injecting the signal out. Well, I have to admit, I'm kind of at a loss as to what might be going on. I just don't think maybe feeding the signal in this way is actually something that can work. So it might be time to start taking parts off of my scrap board. I think this does work even though the whole power supply RF modulator was just ripped off. I think I bodged together in a way that does get this to run, at least where I can see that there's a video output and clock signal. So let's start taking parts off of this and swapping them onto this board to get this actually up and running. I guess we'll just start with the crystal oscillator, because let's just make the assumption that the whole timing circuit is fine and our problem is strictly that this oscillator stopped working. Okay, with the longer leads, this is the one I took off the other board. Okay, and that new part is installed, or the one from the Nintendo at least. Turn on the system, and actually it just looks a little bit different. 250 millivolts on the crystal itself, on both sides. And yeah, 1.5 volts on the clock pin. You know what, it actually looks like we're getting some oscillation. That's fascinating. Not enough to actually generate the clock signal. That's pin 18. I mean, oh, there's something there. It's just kind of there, isn't it? Just, yeah, look, actually, it's just barely there. All right, let's see. This is Q2. Yep, that looks totally fine, NPN. Okay, so with that transistor route, I'm now feeding the 21 megahertz directly into, well, basically the output of that transistor. And now on pin 18 on the PPU, we do have a normal looking clock signal. And looking at the output, the video output, and I have it set for in the microsecond range, set on nanoseconds, I really don't see anything happening on the output of the PPU, which at this point, when we have the clock going into here, it should be working. So now I'm thinking that my little repair job didn't work, or this PPU is just dead in the water. And you know what's funny? It's quite possible the PPU is so dead that it's killing the clock line, and it would kill it for the entire system here. Okay, I did a bunch more dremeling, and I've exposed more of the video output pin. You can see that that copper is now much more clearly exposed. I don't think I was actually connected to it before. So I'm gonna put a little drop of flux on there. We have a little offcut here, and I bent a little hook into it. All right, with no clock signal connected, if I turn on the power and we take a look at the video output now, that's weird. This is the video output pin. I'm not moving anything. So I figured that's because the clock's not working. I'm gonna shut the power off. We're gonna probe the video output pin, turn on the power, turn on the clock. Oh boy. That actually looks like a working signal right there. Yes, that is without a doubt correct video output. So before, the video signal wasn't there because that pin wasn't hooked up. But if we go to pin 18 here, we're not seeing the clock on pin 18, but that's because the speed is not right. We gotta go faster. So there's that oscillator signal. Now the question is, are either of these two original components I took off the board actually bad? With this missing, I was able to properly inject the oscillator signal from the generator, and then that was running the console. Clearly, looked like it was running. I bet if I plugged a cartridge in there, this thing would probably work at this point. But what exactly is going wrong with the clock generation circuit? This tested good. The transistor tested good in my little tester, so I might as well just put that back in the board. Okay, I put the transistor back in, and that looks okay, I think. Let's look at the video output. Yeah, it looks like we have a video signal there. Okay, so it's all working right now. Question is, let's swap back to the original crystal oscillator and see if the whole time the clock was working fine and I was just mismeasuring it by having this set to the wrong time base. Okay, NES crystal is out. Let's put the original back in. Okay, moment of truth. This time base, 10 US, this is appropriate for looking at the video signal. Let's turn this on. We have a video signal. If we take a look at pin 18, the clock input, we're not really seeing anything, which I think is what I saw before. And yeah, there it is. Oh boy. So the whole time, the problem was simply the video pin was not connected. And obviously when I initially went to look at the clock signal, I had the time base set incorrectly on the scope. And therefore that 21 megahertz signal was just wiped out because it was sampling too slowly, because I was looking for a 15 kilohertz video signal. And with a scope like this, at least this cheap one, the high frequency signal of the clock was just not shown at all. And you just saw it when I had to set for what, 10 microseconds, it just looked like a line, a solid line. When we went down to 25 nanoseconds, which is the time base we're at now, we saw the clock. So I'm pretty confident now in saying the entire time the clock was 100% fully operational. And the entire issue was the fact that when I thought I had reconnected the video output from the PPU, I hadn't. And then I went down this whole rabbit hole of the clock when in reality there was nothing wrong with the clock. So this is a perfect example of where you can make a mistake with your equipment that I theoretically should know how to use, and yet I just went down the rabbit hole on a problem that wasn't actually there, when, yeah, the reality is I just need to Dremel more of the chip away to get to that leg. So, as Dave Jones would say, trap for young player. And I guess young player, right here, right here. Well, to really get an idea if this is actually working, let's try using the old PowerJoy PJ8 cartridge. And I did connect up the first controller. That's this cable right here. And the reason why is I want to be able to manipulate the menus once I power this up and we see a video signal and see if we see any changes on there. So here we go. Power on. Yeah, I'm going to say that that is working, and that basically we're looking at the various bits of text on screen. Okay, so I had it looking more stable, but I think this thing crashed because we're not seeing any display at all. So let's turn this off and on. Okay, so this is one scan line, by the way, and that's why it keeps changing, because we're just looking at random scan lines as the beam scans down. Let's power cycle this again. Actually, I don't know. Like, I didn't touch anything there, and it just sort of looks like it was doing something, displaying something, and then it crashed. Or it's not displaying anything anymore. I think we're definitely having crashing issues. Let's make sure the cartridge is plugged in all the way. Yeah, it is in all the way. So theoretically, we can, like, go down, hit start. Oh, yeah, okay. Oh, yeah, look. That's different. Like, we're in a game of some kind. And let's hit start again. I don't know what game we're in. I just picked random stuff. We can kind of make the assumption, though, that the game console is working. It's doing something. If we poke around up on this cable that's going to the little RF modulator box, we should be able to see the video signal that's going here. And that's it right there. Now, this is going through that transistor buffer, the one I reinstalled in the board. And, you know, look at the voltage, we're up at 3 volts. And I guess that's what the RF modulator circuit up here needs, which is why we have to redo this whole video output circuit to make a composite compatible signal, which is 1 volt peak to peak. You can't really just feed this into a monitor. Although, actually, now we think about it, maybe we can, at least for just quick testing, by hooking up a blocking capacitor. Let's try it. So this is the video signal that goes to the RF modulator, and there's a little via there. So I just plugged a cap, or 1 microfarad cap in there. And that's a lot better. Look at that. Max is 1 volt now. Let's try hooking this up to the retro tank and just see what it does, see if we can see anything. I'm not expecting it to look good. We should be able to just see something, though. So here's our retro tank video input. Let's turn on the power. Oh, yeah, we do have a signal. It's dark, but it's there. Oh, and it crashed immediately as soon as I touched the console. Let's try to reboot it. Oh, it's dodgy, all right. Okay, what I never did with this is put any deoxit in here. And who knows if Jan ever used this console. Since this thing had that broken pin on it, it's a good chance that this was never really used. A little deoxit is necessary. I'm just sort of putting it back in and out the cartridge. There we go, now it's in. Let's see if that made a difference. It's gonna be dark, but we just don't wanna see corruption, right? Okay, here we go, 3, 2, 1. All right, oh yeah. What were we doing? Goonies. Of course, I don't have audio hooked up. Oh no! It's still working though. So we can start games. What's going on here? I'm not touching anything on here. Why does it think I'm pushing buttons? I wonder if that's because the other controller's not connected? No, it can't be that. It cannot be that, but you know, I don't know for sure. Perhaps the way this is designed is that since the controllers are always supposed to be connected, when they're left floating, causes weird issues. And who knows, with this game cartridge, could be you could select a game with either of the controllers. I don't think that's going to be what's causing our corruption in the graphics, but maybe that's what's causing that menu selection problem. Oh, nope. It just like zipped all the way to the end on its own. What the heck? I don't feel like the corruption is like a connectivity issue with the cartridge. Well, I went and grabbed another cartridge. This is Galaxian, my only other Famicom cartridge that is not an Everdrive. I don't feel like plugging my Everdrive into here because I just don't trust that everything is working properly with this console. I wouldn't want to risk causing any damage to it. Okay, Galaxian is in. Okay, so far so good, no corruption or anything. Start. We have good color, so we know that the crystal oscillator is working. Right, so this works. How odd that the menu on that other cartridge was just like scrolling on its own, and we had that garbage as well. Now, as a reminder, the reason why this looks dark is because I'm just tapped right into the output that's going to the RF modulator, and the voltage levels are not correct, obviously. But, you know, we're getting color. Oh, the console just froze. So hit reset. Oh, it just freezes immediately. Interesting. Let's try 2-player mode and see if the other controller works. Okay, player 2. Oh, that does not work. Oh, and now controller 1 is acting up. Huh. Whoa, it just reset itself. Let's do 2-player again. Okay, player 1, no problem. Let's try player 2. Player 2 ready. Nothing. I cannot move up, down, left, right. No fire button. Interesting. Player 1, still working. Pause works. All right, let's do a quick recap. The clock circuit on this console probably worked perfectly from the start, so me mucking around with it was completely unnecessary and a total waste of time. The reality was the video output on the PPU was not working because that pin had broken off, and I thought I had reattached it, and I hadn't. So a little bit more work with the Dremel, I got it reattached, and now we can see that we have good video output. But we're still not fully out of the water. This cartridge seems to freak out and go corrupted on us, weirdly enough, and then it starts selecting stuff in the menu randomly. So I put in Galaxian, which seems to work. It did freeze a few times, oddly enough. Player 1 works, but player 2, that controller just seems to be totally dead. So I think the first thing to do here is let's sort out this video output issue and get a nice, clear composite video signal from this. Now, I went and printed out schematics for possible video output mods for this console. The thing is, now that we know that we can just hook up to the existing transistor and get a video signal that's just not quite the right levels, maybe we can just modify the circuit that's on the board to just output the correct levels and not have to really do any mods at all. This particular mod, which looks like it comes from Usenet originally, tells you to take the transistor off the board, the one that was off the board when I started working on this, and then add these components, and you get a nice composite video output. Now in this circuit here, the video comes directly out of the PPU on pin 21, that's the one we fixed. It goes into the base of this PMP transistor. The collector is connected to ground. The emitter side is pulled up to 5 volts through a 300 ohm resistor. We have a tantalum that I think has something to do with the filter. It talks about it on here. It says 10 microfarads is a good value for that. Another electrolytic that's going to block the DC. And then we have a 110 ohm resistor. That's part of the termination. 75 would typically be what you have here, but I guess for the whatever levels this creates, 110 makes more sense. And then we go composite out. And again, like I said, I don't know why we wouldn't want to just reuse what's already on the board. We just have to alter things like these resistor values and maybe add inline capacitor to block the DC. So the biggest change when looking at this schematic is that this 2.2K resistor is now 300 ohms and the 220K resistor is 110 ohms. And then in line with the output, there's the output, they have this 220 microfarad capacitor. Yeah, this should be easy to replicate directly on the board without having a whole bunch of stuff on here. And the plan is once we get the video output working on here and then the audio working, the idea would be to then tackle whatever's going on with the console where it's doing that weird crashing and we're getting those spurious controller inputs. All right, so first things first, I need to remove R12 and R6 because we're going to be changing the values of both of those. All right, just like that, we have R12 and R6 out of the board. And we'll just start with the values that are on here. We might have to change them if these don't work well, but 300 ohms for R6, 110 ohms for R12. I don't have the exact values, so we're going to be using 100 ohms in R12. And instead of 300 ohms for R6, we're going to be using 324. And you know what? I'm looking at the way our modulator is connected, and I'm pretty sure the video signal, which goes from here to there, goes to where there's a jumper link that's not installed, and then it goes to a capacitor. We can just reuse this capacitor. We could just take the video signal off of this point. We just need to remove whatever component that is next to the capacitor. All right, so the capacitor that is in there is 10 microfarad. It looks like 16 volts, and there was a little resistor, and I've already kind of dislodged it. Unfortunately, this can, there it is, that's the little resistor. So unfortunately, this can doesn't really come off very easily. You have to desolder from the whole board, so I'm just gonna try to kind of work around it. Okay, so the resistors have been soldered in. I'll just leave the legs there in case I need to take those out. This is all reconnected, and then I have the capacitor on the other side of the board, and this one's just tacked on so I can easily probe or clip onto this video signal so we can look at how the video signal looks when it's actually hooked up to something that's 75 ohms terminated. And with the retro tank hooked up, which has a termination resistor, let's see what it looks like now. Okay, it looks really weak, really weak. So I feel like this assortment of resistors here didn't quite do what we wanted to do. So I put 100 ohms there and a 330 there. I think I need a stronger pull up to 5 volts. So I put the 220 ohm resistor that I had on the board on the top side originally. I stuck it into that position that had a 330, and let's just see what that does for the video output signal strength when I turn on the console. We're not looking at a full white signal, so maybe this is actually fine. Let's put a cartridge in. What is this going to look like? Better. That's a lot of dot crawl though, isn't it? That's a lot of dot crawl. And I know that there's definitely issues with this console with the jail bars. And that's because the video signal just runs right near a bunch of data signals. Now, I don't have any of the controllers plugged in right now, so the game is just going to run on demo. But you know what? That actually looks quite decent. Quite decent, actually, isn't it? I'm kind of curious about using this RCA jack. I wish it was easier to open this can, but it really is not. I can see where the RCA jack is connected to the board. It's right there. That's the connection to the board. So I'm just going to remove this solder so we can hijack this. I'll just run a bodge wire from right there with that capacitor in place to there, and that should give us video output right there. So I'm just removing the components that disconnects the RF output, so we won't be sending RF into whatever we plug in. So that capacitor is one of them. And I think that inductor L1, I think that's the other component. Yeah, that's definitely the component. I removed one leg of it already. Okay, there's the little video bodge wire. So we plug in the composite video output. Let's see how this looks now. All right, here we go. Yeah, same. Now you can reduce some of the artifacts and the dots by adding some capacitors to add some filtering, soften the picture basically, but it's a trade-off. How sharp do you want it versus how bad do you want the dots to look? When you look at the video output on the original NES with this printout, there were those filters that were installed, those inductors and things, and that's what's going on. There's a capacitor and an inductor that forms a filter that will soften those dots. Okay, I have the controllers plugged back in. Let's turn this console back on. Let's see what's happening exactly with the two-player mode. Are we still having the same issue? Now, I know I haven't solved the audio issue, but I am just curious to see if we're still having those other problems. Okay, player 2. All right, ready, player 2? Yeah, we don't have any activity on here. Maybe player 2 doesn't even use the second controller? Is that possible with this game? This is an old game, and you are supposed to take turns. Let's see if that's the case. That would be hilarious if that's what's really going on. Oh, nope. Nope. Neither controller does anything. Okay, back on the multi-cart. Oh yeah, look, we have color text. Let's see, do any games actually work? Well, Arkanoid works. Actually, it looks pretty good, except for the jail bars, which, you know, obvious, that's the problem on the Famicom. Now there are some fixes for the jail bars. This talked about it, putting like a tantalum cap between, I think, the 5 volts on the PPU and the ground. And that might help the jail bars, but I'm not quite sure. I think really you need to reroute the video signal away from all these data signals. Okay, so other controller doesn't do anything. Goonies. Ooh, jail bar, city. Oh, okay, look, we're having some issues with the video signal here. So this is due to my crappy composite mod. I think, you see how it actually disappeared there for a second as well? I think that might be due to the fact that the capacitor that's on the RF modulator that I'm reusing is not big enough. Oh, there, and then we're just getting that corruption as well. But you see how it's light at the top of the screen there? All right, so I put a 100 microfarad cap, 50 volts here, instead of whatever was on there. I think that fixed the problem. I mean, this cartridge is having an issue, as it was. Notice when it goes black, we don't get any kind of weird, like, light sections. If I could run Goonies again, I could demonstrate we saw a really good example of what was kind of messed up at the top of the screen there. So I really need to get into Goonies. But it just seems to mess up right away when we try this cartridge. I don't know what's going on. It's weird. I wonder if it's somehow incompatible with these original Famicoms, because I know this cartridge is like a 3.3 volt cartridge, and this thing obviously is a 5 volt system. And you know what, thinking about it, the CPU and the PPU on here are an older revision. And what if this older revision has a problem with this cartridge? That could be what we're experiencing here. All right, what I think I'm going to try to do is remove this other capacitor that's on this board, the one that's too small, and I'm going to install this bigger one on the underside. And that will just make this mod a little bit more permanent, a little bit less ugly than what we're looking at here. Okay, the mods are now internal. Turn it on. Okay, everything looks fine so far. Saw a little glitch on the top of the screen. Oh, yeah, okay. So there's still definitely issues with this console that don't relate to the video output or anything like that. I think I'm gonna have to grab my Everdrive because I have some diagnostic utilities on there. We need to run those, especially to see if like the second controller works at all. Maybe if this is strictly a problem with the rubber pads under there. Okay, the Everdrive is in. Let's see if this works. Boots up. Okay. Seems fine. Oh, no, it's not fine. The problem was the Everdrive takes a lot of current, and my power supply was only giving 400 millivolts at 7 volts. Not enough. Let's crank it up to 800 milliamps, 7.14 volts. Let's see if that's a bit better. Yes. Oh, what happened here? I can't even control it at all. Weird. Huh. It's very strange. We're having some issues. I'm going to crank it up to 9 volts. I wonder if we're having like a bad connection here. All right, let's try that again with it flipped over. I can't control it. Oh, well, that's weird. Pushing start select does that. Pushing the buttons does that too. No, just start select. Oh, no. Yep, buttons. What is going on with this? Does this second controller do anything at all? No. Absolutely nothing. Okay, so if we switch back to Galaxian, that was where to hit start. Oh, what is happening here? This is one unhappy console. I don't know what it is. It's hard to do testing on this thing when it's so flaky. My video mod has nothing to do with what's going on here, by the way. This is some other problem on here. I really wish we could get the Everdrive booting, because then I could just run the diagnostic utilities and, you know, test the SRAM and that type of stuff. Because right now, thing is like degrading and it's getting worse. Wow, what is going on? It's like the PPU is dying or something, to be honest, because that kind of glitching we saw, like it was blipping in and out. I don't see how that can happen. Like no software problem, like crashing, bad connection could result in that kind of thing. And everything is okay. Nope. No. Wow. Okay, console is running. Let's check out the clock signal. That's this pin right here. I mean, it seems kind of glitchy. I'm holding the probe steady. It's sort of all over the place. Look, just in case we're having a probing problem, I soldered a little offcut onto pin 18 on the underside here. That way I can just clip on. I'm not touching anything. And let's see what that looks like now when we power this on. What is happening here? That's an unhappy clock. It's blipping in and out. Is it possible that that crystal oscillator is bad? The one I took out and put back? I'm touching it with my finger right here. A little bit of a touch these other things here. That's the capacitor. It's coming and going on its own though. Something's very wrong here. All right, so I think we pretty much confirmed that we absolutely have a problem with the clock circuit here. Oh, this looks bad, very bad. It's not my scope, is it? No, everything seems fine here. Whoa, is it this? Oh, you don't tell me that this scope is the problem. I just put a drop of Deocta D100 in there. Let's see if that. No, I don't think that's this. I don't think that's the scope. All right, I don't know. I'm just going to grab a different probe. I'm not 100% trusting this one. Okay, I grabbed other probes, not compensated perfectly, but look, poking at it doesn't seem to change anything. So I feel more confident about this one. And there we are. I'll clip back on to the signal, and it seems to change. And it looks kind of crappy, but let's power cycle, game console. Yeah, it doesn't look that great, does it? Let's poke around with my finger. Oh, what happened to it? It's gone? What? Power cycle? Oh, okay, yeah. There's gotta be something wrong with the clock signal. There's gotta be. I'm not even touching it. Look at what's happening here. I don't know. We've lost it entirely. Now it's back. What's happening? What is happening? Okay, I think it's time to take some parts off here. I put the original crystal back on here. It's not soldered in, it's just sitting on the board. So I'm going to reinstall this one on the Famicom. And if that doesn't change anything, then I'm going to start swapping over the transistors. They're right here, the two. And if I need to, I'm going to keep going and swapping over these other components as well. We got to get this clock stable and looking good. Otherwise, this thing is never going to work properly. And my assumption is the weird freezing and crashing has got to be a clock problem. All right, the crystal from the NES parts board is swapped over. That does not look better. Nope. That is problematic. It's still changing on its own. So I don't think this is a bad part. I'm just thinking transistors or something else. I'm poking around here. It's not really changing, but still something's up. I removed both transistors and I took this transistor you see on the board from the NES parts board. And this is the original crystal from the Famicom back in this board. So without Q3 installed, the CPU will have no clock. So it's only going to the PPU, which is what we're looking at here. Let's turn this on. Well, that looks good. That looks completely good. So this transistor was Q2, the one that was on the Famicom. And I don't know if this was the bad one or if it was Q3. I'm going to install Q3 that was from this board back into it. Q3 is in, because obviously these two things are kind of connected to each other. So it's quite possible that Q3 is the problem and was affecting Q2. Okay, we're ready to see how this looks. 3, 2, 1. Well, that looks totally fine. No issues at all, nice and stable. So we have the original crystal oscillator. I have the Q2 from the parts board, and Q3 is the original one from the Famicom. So all I've switched out is this one here, which was Q2 that was originally on this board. And without a doubt, this Q2 transistor is the main one that makes the whole crystal oscillator circuit work. And I guess it's bad or something. So the proof is in the pudding. Will it be more stable running these cartridges? Will it glitch out and crash like it was doing before? Let's start with the most problematic cartridge here, the PowerJoy 8. Okay, here we go, 3, 2, 1. I do have it hooked up to video. Where's controller 1? It's hanging down here. All right, well, so far so good, but we've been here before. There is some interference patterns besides the jail bars, so we have that little bit of static on there as well. So not ideal. But we don't have any issues with the light section of the video at the top anymore, which I had with that other capacitor in the RF modulator, the original one, before I swapped out that 100 microfarad into there. This is the best this console has worked since I started fooling around with it, right? Okay, well, the fact that it hasn't crashed kind of implies that the glitching was what was causing, the clock glitching was causing the crashing on the console. It's got to be that, right? I don't see what else it could be. Oh, I got to rescue another kid. Cool. The game's not crashed. It's working without issue. Let's turn this off and switch to the Everdrive. Because if I can get this to work properly, and we can actually select stuff. Oh, wow, I can actually select things. You're kidding me. So I can run the 240p test suite. I suppose what was happening was the Everdrive itself relies on the clock signal. Maybe the clock signal that I think goes to the cartridge port wasn't working properly. I think we have an input test here. Serial analyzer. I think we can do this to test all the inputs on here. Okay, so that's the first controller working fine. But the second controller doesn't do anything at all. And where does that show up? Does that show up on D2 or D1? Okay, nothing's happening on the second controller at all. First controller though works. Okay, so first controller good. Second controller, nothing. Looks like the microphone button is working though. So there's a volume slider on here. If I slide this all the way to the top, then it actually works. And the whole point of this is you're supposed to be able to affect the other player while player one is going. You can mess with them and stuff. Now the question is, are we having an issue with the shift register in here, or the buttons not making good contact? I have a little bit of a hard time believing that the contacts or the rubber pads in here are totally dead. Really screams that there's some other issue. All right, well, let's use the oscilloscope. I'm just probing around the various pins here, and if I push the A button on this controller, you can see that there's some activity there. Oh, and that was, this is up, down, and that's the up key, down, left, and right. We got to slow this down a little bit more. Okay, how about now? Yep, okay, so we can kind of see what we're doing by pushing on the various buttons. Cool. On the good controller has like a pulse signal on there. And if we go to the controller that doesn't work, and let's find that pulse, there it is. It would imply the next wire over is the output of the shift register, and it's just high all the time. So I'm kind of feeling like the one that's high all the time, this one, is our problem. I think that should have the output of the shift register on here, and it's just doing nothing. So I did a little bit of reading about how the controllers work, and it's a shift register. So there's a signal that comes from the Nintendo that goes to the shift register that tells the shift register to latch all of the inputs. That's all the buttons on the controller. And then there's another signal which pulses, which is like a little clock signal, so to speak, that goes to the shift register. And then there's a data line that goes from the shift register into the Nintendo. And when each of those clock pulse happens, it shifts one of the bits from the shift register back into the Nintendo. When we looked at the output of the shift register on the first controller, we could actually see different buttons I was pushing. You know, we could see that little waveform that was happening. That's the data signal. And I didn't see that coming from the second controller. Now, looking at the original schematics, here are the two controller ports, P4 and P5. P5 is the second controller port that has the microphone input, so there's an extra signal on it versus the first one. Now, when we were running the diagnostic cartridge, and we could see all those different bits of all the different controller inputs on the Nintendo, and I wasn't sure where the second controller would appear. Well, we can see right here that it appears on 4017. That's an address in the memory map of the 6502, and it's controller 1 that shows up as 4016. So both of the controllers show up on D0, but they show up on different addresses. So 4017 for the second controller, 4016 for the first. And we definitely didn't see any activity on 4017 on D0. Now, incidentally, on the expansion connector on the Famicom, there are other data lines, the D4, D3, D2, D1, along with 4016 D1. And those are all available to be used by external peripherals like the Zapper, the family basic keyboard, and all sorts of other things can use those. Some of these signals are available on the controller ports on the front loader NES, but the rest of them are available on the underside on the expansion connector. On the Console 5 wiki, there was actually some recreated schematics that are a little bit easier to see, showing a bit closer up how the joystick connectors work on the Famicom. And there's Joy 1 and Joy 2 with all the signals we just looked at. And we even have schematics from inside the controller itself. And there's the shift register, the 4021. It's the same on both of them. It's just there's no start and select on the second controller. Plus it has this little microphone circuit, which uses a 4069 and then sends the signal into the Nintendo where it's processed there. So on both of the controllers, the out signal that comes from the Nintendo, that's that pulse I was mentioning. This goes into the PS input on the 4021. That's the parallel serial input that switches the shift register between parallel mode, which is where it's sampling and latching all of the buttons and whatnot going into these P inputs, and serial mode, where it's outputting all of those outputs out of Q8 into 4017 DO or 4016 DO for the first controller. And then the clock signal, which is the pulses that is shifting that data out, that is 4017 C up. So I think the first thing I need to do is, with the cover removed from the second controller, I need to just make sure that we have connectivity from the various pins on the shift register to the connector on the motherboard. Because if any of those aren't working, or there's like a break in the connection or the cable or whatnot, then clearly we're not going to have this thing working properly. So multimeter is in continuity mode. The first relevant input we're going to look at is the data line that goes from the shift register back into the Nintendo. That's where I didn't see any activity. Now, according to the schematics, pin 3 is the data line. We just don't have anything. There's no connectivity there. The next pin on the motherboard is the out pin. This goes to pin 9. Pin 9, that is definitely connected. Next up we have the clock signal, which is pin 10. That is connected fine. And then we have the VCC pin that is connected correctly. And then ground is down here, which should be there, and that is connected. So on the schematic, it was the data line 4017D0 was not connected through to pin 3 on the controller. So there's no way that signal is going to work. So first let's see if this is making its way to the connector here. Okay, it is. It's the orange wire, and there's the orange wire, and it's not on the orange wire. Well, that's a bit of a problem, isn't it? There's like a physical break because I'm touching the orange wire there and the orange wire here, and there's just nothing. I guess it's just not something I ever would have thought would be the problem. This whole console is in really good shape, and I don't think the wires are eaten, like there's nothing obvious, and there's no obvious damage to these cables, and like none of the wires seem broken. So like, where is the break exactly? And again, I'm poking into the orange terminal there, and nothing. Absolutely nothing. Now things look a little crimped right here, like the orange wire does. So I wonder if the break is like right here. If that's the case, that's excellent, because well, it could be anywhere in this area too, but that's super unlikely. It's just, this looks a little, I don't know, crimped, I guess. So I'm going to cut it right here and see if we have continuity in there. Let's grab something to cut this with, and if it is, I can just extend it. Okay, it's a bit precarious. Oh yeah, I have continuity there. So the break is like right here in this part. You just see how it kind of looks like it's twisted a little bit or squished. So the break is in there somewhere. Don't know where exactly it is, so I need to give myself enough length to add a little extra length of wire. Okay, let's see if this part has continuity. Oh, it does not actually. So the break is between the probe, the black probe, and this little piece of wire here, in this little tiny section. How is that possible? Unless when they crimped this, they didn't actually strip the wire off. So like there's insulation under there, because I was actually just on the outside there. I am struggling to get this apart. I don't know how this is supposed to come out exactly. I figure there's a tool that you have to stick down in there. That's why I'm trying to use this, but this doesn't seem to be releasing it. And I don't really have any other tool with this little kit that would even be appropriate to try to do this. Okay, well, I can't really get this out, and I need to make this work. So I have two choices. I can either extend this orange wire from the controller and just solder it onto the motherboard, but then that would make this unremovable. And that's annoying, and I really don't feel like doing that. So I think I'm gonna actually melt into this connector a little bit, expose the crimp part. You can just see that the metal crimp right there. And I'm just gonna solder a wire directly onto that, and then I can extend it to that part there. I don't really know what else to do. There's something I'm missing, or that tool's too big, which is probably the case. I need something much smaller, and I don't have that. So I've exposed a little piece of the crimp right here, and what I wanna make sure is that it is actually connected through to the other side. Yes, it is. Cool. So that means I can try to solder a little piece of wire right onto that little exposed crimp there, and then, well, you know, extend it to the controller. Okay, so there's the quote-unquote repair. Let's see if this actually works. You might notice a few other little mods that I've done to this board. Since you last saw it, literally just a moment ago in this video, but for me it's the next day, I actually installed these little bypass caps between the 5-volt rail and the ground plane. And this was in an effort to reduce the jail bars. And you know what? This works. I also added this little tiny 101 cap to the video output just to smooth it ever so slightly. A 102 cap would have been probably a little bit more appropriate and smoothed it a little bit more. But this cap on here for the video output plus these caps, just trying to fix the jail bars, that made a big difference. These are 22 microfarad ceramic caps between the 5-volt ground plane and ground. And I stuck them in these 3 locations just arbitrarily, just because 5 volts and ground plane were right next to each other. So I thought, well, there's as good a spot as any. So I just ground away some of the solder resist and soldered those on. Oh, one little tiny mod I did, I cut those 2 traces. Those 2 traces supply power to the RF modulator. Obviously the RF modulator should be disabled now, but I noticed a little bit of interference on the video out. I thought that could be caused by interference inside the can. There's some oscillators and stuff that are running in here for the RF modulator, and without power, then obviously that won't be the case. One of these is 5 volts all the time, and the other one is switched 5 volts. I'm not sure why the RF modulator runs all the time whenever the power is connected, but that is just the way it was designed. So with those two traces cut, there's no more power for any of this. I mean, there are still jail bars if you look at the gray section down below, but they're less. Well, unfortunately, that fix didn't work. I must not have made that connection firmly, even though the wire felt like it was on there properly. The flashing you see on D2 is actually the microphone input. Yep, that's how the microphone is registered by the Nintendo, the activity on D2. We should be seeing on 4017 D0 all the controller inputs, and we're not. Time to take the controller apart again so I can just test continuity all the way through. I will mention with these bypass caps, I've done the same thing on an Apple II before to try to fix the jail bar issues on the 2 Plus actually. It was quite bad on that particular RF board. So I did a very similar thing to this, and actually it completely eliminated them on the Apple II. All right, so we're gonna be looking for continuity from the orange wire. We don't have it. Come on. I was digging around inside and it just looks like the original wire was not attached properly, like it has the insulation still on it. I pulled the actual center copper out and just came right out with no issue, so it's not actually touching anything. And I guess the reason why we had no connectivity is this was actually just sort of melted onto the plastic. It's really hard to get in there and do this microsurgery. Oh, would you look at that? Freaking works. Well, the connection is there at least. So after ripping out the little end piece of the orange wire, I was able to really accurately get the blue wire connected up. And well, it's at least connected. Let's see if things are actually working. Serial analyzer. Okay. We know it's working because D0 now has a bunch of white boxes, and that's because there are only 8 inputs from this shift register. If you use a Super Nintendo controller, for instance, you actually end up with 2 of those blocks because you can use an SNES controller on an original Nintendo, and the 2 extra shoulder buttons and I think the 2 extra trigger buttons are on that second block. So most software doesn't really use it, but the first set will work. And there we go. That is fixed. I'm pretty confident in saying that 99% this problem has existed the entire life of this console. I don't see how that problem could have crept up after the fact. So maybe this particular NES was just never used in 2-player mode its entire life. Or if it was after it was out of warranty so that someone didn't take it back to get repaired. All right, here is our controller up, down, left, right, A, B, and there's no start select. And we know that the microphone does work. If we tap into it like that, works fine. So this thing works perfectly. No issue with the rubber membranes, and yeah, it's in really good shape, other than the freaking wiring problem. Oh. So we're nearly there with this console. Both controllers are working. We have really good video output, well, as far as you can get on a Famicom without completely rewiring the video circuit. And all that's really left now is the audio circuit. Oh, I do want to add one thing, that when I took a break last night to go have dinner and stuff like that, I left this running for a couple hours, and there's no more stability issues. This thing is rock solid. All of the weird random crashing we were getting was entirely due to the clock signal. So now that the clock is fixed with that new transistor Q2, we're golden. This thing is working perfectly. Now, when it comes to audio, it's a little bit complicated on the original Famicom. Here is the actual connection that goes to the RF modulator, and you'll notice it goes to what is labeled as P1, which is the cartridge connector. And that's because on the Famicom, it passes the audio from the CPU, which generates the audio, into the cartridge, and then it comes back from the cartridge and it goes out to the RF modulator. Because if we take a look at the CPU, I think it's aux A and aux B. I don't know why it's labeled that way, and these are kind of mixed together with some resistors. And there's also R3, which I'm pretty sure is coming from the microphone on the extra controller. I think that's the microphone audio, because when you talk into the microphone input, you will have sound there. And we follow this trace over, and I'm pretty sure this goes up and it gets buffered right here. A 4368, this IC is a bit like an op amp, and there's a bit of a resistor going on there. And that buffers the audio, and it goes into the cartridge connector on pin 45. And when we take a look at the audio signal here, I think this is on 46. Yes, it's on 46. So if a cartridge, probably like this cheap one here, doesn't support audio, the PCB in here needs to loop 45 to 46 to pass the audio through to the RF modulator. So what that really means for picking up audio, the audio that's going to the RF modulator, which happens to be this third pin from the left, Well, that's already buffered. It's going through that op amp. And when I looked up how people typically hook up audio to the Famicom, they just hook up directly to that line. Well, not quite directly, because there is a DC offset, apparently. We'll just look at that with the oscilloscope in a second. But if there's a DC offset, we'll just put a blocking capacitor in there. And then I was just going to use something like this little RCA connector offcut thing. And since I'm missing the grommet there anyways, I'll just run this out there, tie this down like with a zip tie or whatever, and then we can solder it onto the board, and that should be our audio, theoretically. So we will need to do a little bit of surgery on here, because obviously, just like the video was, the audio circuit, which is this one, is connected through to various components. So let's first take a look at the audio output and just see what this looks like going into the RF modulator and make sure we do have audio right there. And let's just start with Castlevania 3, because we know this has nice expansion audio. We definitely have a DC offset, so let's put this to AC coupled, bring this down so it'll start triggering properly, and we'll start actually seeing the audio waveform. And there it is. There's an audio waveform, and that's definitely the music playing. And 270 millivolts, it might be quiet, but it's going to be good enough. You just turn up the volume on whatever you have this plugged into, since we're not going to be adding any kind of transistor buffer amplifier to this. Ideally, you'd need to use an op amp if you want to amplify the signal inside the console, so we're just going to use it as is. So for removing DC offset from audio, typically you might want to use something like a 10 microfarad capacitor, and this 10 microfarad capacitor happens to be the one that was inside here that I took off of the video circuit when I replaced it with 100 microfarad. So I'm just going to reuse this one for the audio output. So I'm going to start taking some components off. I'm going to take that one off, I'm going to take that one off. So let's take a look at what these components are. These two are outside the can. The can starts about there. It looks like we have a small little capacitor and we have a resistor. Maybe we'll leave that capacitor in place, but we'll take out the resistor, since this looks like a good enough spot as any to use the DC blocking capacitor. Now the problem is what's happening in here, which is where we want to pick up the audio with our RCA cable. We're going to need to remove these components. So there's that component and this component. We're going to take those off, and that way I can use those vias as the point to solder the wire to. Oh, these ones are really hard to get, the ones that are inside there. They've already fallen out. They're floating around in there. Maybe I'll just have to tip this over to try to get those out. Oh, there was one of them, a little 1 microfarad 50 volt cap. Interesting. And I think the other one, oh, there it is. It was a little tiny resistor, had fallen out. Cool, because I couldn't really get in there anyways to get to those. Right, here's our little 10 microfarad 16 volt jobby. This is the one I'm going to use in here. Now you put the positive side towards the voltage source, which is the audio output, because remember we have a positive DC offset. The negative side goes towards the output. Okay, so the cap is attached right there. If we flip it over, it's that one. Negative side is facing this trace here, and this is where we're going to connect the positive going to the RCA jack. Just like that, we're all connected up. I'm just going to do what the controller wire does and just loop around that standoff there. I don't have the audio hooked up yet. Just going to make sure we're up and running. Looks good. And let me grab the audio cable and plug this in. Here we go. Is this going to work? Yep. It freaking works. Heck yeah. Awesome. Oh, it's really buzzy though. Interesting. Wonder why. Okay, by buzzy, I mean, let's reset the console. There's a ton of audio buzz on here. Well, that is interesting. Let's take a look at this with the scope. Okay, I'm going to turn this down since it's very annoying sounding. If I'm on the negative side of the cap I installed, we see that. So if we go to the side that's facing the console, you see there's a bunch of DC offset that's getting filtered out by that cap. AC coupled, and there's the side that faces the console, and it's also noisy. I'm going to unplug the cable that goes to the speakers. Still noisy. Where's this noise come from? All right, so there's the audio signal on the motherboard side. This trace is going to go to pin 46 on the cartridge connector. Okay, so there's pin 45, and this is pin 46. So the audio is actually there going into the cartridge. Now, part of me wonders if this is happening because there's filtering in the RF modulator that obviously we're not using now. We're just listening to the audio directly out of the cartridge, which really comes from the CPU. So I popped out the Everdrive. I'm just going to poke around a little bit with the console turned on. I want to see where the audio, what the path it's taking is. Like where's that buffer chip from the CPU and where the audio was kind of introduced. because this is actually kind of curious. I'm on pin 45, there's no cartridge on, but the console is turned on, so there should be a video signal. And yeah, we just have a solid blue screen, which I guess is whatever. But you'll notice that we do not have that noise. I wonder if it's somehow related to this cartridge. Let's try a different cartridge. Pop in the Galaxian cartridge. There's that noise. And it should be on both pins. Yeah, it is. So that's the output that goes to the RF modulator, or what we're listening to. And that is the input. Now, my assumption is this audio noise is 60 hertz, like it's the video signal we're listening to. The question is, why isn't this noise there when the console doesn't have a cartridge inserted? I'm going to push the reset button. Seems to be less. And it kind of comes back, depending on what's on screen. So this might entirely be my fault for just using this really crappy cable here. So I'll just try to keep this cable sort of in the middle here, away from this other stuff. Turn the speakers up. So yeah, so there's the buzzing. I push a reset. I hear other noise. Yeah, how interesting. So it's not related to being near the controller cable. This is just noise on the whole system. Okay, so what's weird is the noise is gone, but is the console working? Is the sound working, I mean? No. So that's why we don't hear any noise. What happened here? Where's the sound? All right, so there is no audio coming through on the scope right now. What about on the other side of that cap? No. What's going on? We've like lost the audio. So I'm looking on both sides of the cap. It's not there. So it's not the capacitor. We've lost the audio somewhere else. Hold on just a second. I'm wondering if these joints here, this is the audio, 45 and 46, those look a little weird, like they're not connected. I'm gonna reflow those. No, as soon as I turned on the console, there was buzzing and then it went away. It was there and then disappeared. The audio is like coming and going with like weird noises. Yeah, we don't have any audio going into the cartridge connector. You hear that, the noise it's making? Like there's an audio problem happening somewhere else on this board. You know, part of me is sort of surprised at how many issues we've been having with this particular console. It's kind of never ending here. So this is the audio buffer that takes the audio from the CPU and buffers it before it goes into the cartridge connector. So we're either having a problem with the audio output from the CPU itself, or we're having an issue with this IC, or potentially like a bad trace, bad connection, that kind of thing. So let's do a little bit of tracing. So the audio looks like it comes out of pins 1 and 2 on the CPU. They make its way to R1 and R2. These are both connected to ground, which they are, and forms a voltage divider with R5 and R4. So that one is connected there, and these two are connected together, and that looks good. All right, and this resistor is 12K, just making sure it's not open. The way these are hooked up together, you can't really measure them because they go through the other resistors and whatever. And this one here is not open, yeah, 7K as well. And the output of the voltage divider, these two resistors, they go to this 1 microfarad cap right here. And let's make sure that that is hooked up properly. It is. Both of those make their way to this. Question is that cap good or bad? I guess what we can do is get this running, like running a game or whatnot, and look at the audio output from this cap. But the output of this cap should go to pin 14 on this IC, which is right there. So that's the audio buffer happening. And there's also this 100K resistor, which should be hooked up on one of the leads. Yep. Other one should be hooked up to pin 13, which is the output, which is right there. And then the output of this should make its way directly to the cartridge connector on the appropriate pin, which is that one there. And it is hooked up. Okay, well, it looks like all the connections themselves look good. The buffered audio makes its way to this loops around and then goes to the RF modulator. So why is the audio cutting in and out? Okay, so all I can think to do is boot a game back up because we need to play some music and I need to poke around to see where the audio is disappearing. It sounds like the audio is working right now. You gotta be kidding me. Okay, I kid you not. I kid you not. This is picking up a radio station with me touching the capacitor. Oh, and now the audio went away. I could hear music coming through. And I don't know from where. Wow, that's hilarious. Let's start this so we can have some NES music here. It's like popping and having issues. Okay, so there's music that's playing right now. Whoa, okay, I got to turn this down. What is going on here? What is going on? I've said that a lot in this video, haven't I? Well, now it's just started working. Oh, there we go, cut out. Okay, perfect. Don't come back, please, don't come back. Because I need to see where the audio is dying here. Let's look at both sides of the cap. So that is music. So that's CPU audio right now. And on the other side of the cap, that still looks like CPU audio. So let's check the little op amp here. So I'm pretty sure this is pin 13. This is the output of this op amp. And the input is this pin. Let's see if this, once this settles, we should see audio. Yep. Okay, well, that tells us I think that chip is bad. This chip is freaking bad. Okay, well, I'm going to take it off of this board. This should have the same thing. There it is. It's TC40H368. So I'm going to swap those chips out. I wonder if this failing internally is somehow causing that extra noise we were hearing, because I bet you these other signals that are on here, whatever they are, might be making their way through to the audio, possibly. Oh boy, I took out the wrong one. It's right here. It's not like it's damaged or anything, but well, that was a waste of time. Okay, so I removed the correct chip this time. This one, it's right near the resistors at the cap. That's the audio circuit. So this is the one from the parts board. And there we go, goes into the socket very easily. We're all back together, ready for testing. Galaga is installed in here, or Galaxian, I'm sorry. And let's power this up. There's a lot of buzzing, but let's see if we have audio. We have audio. And it sounds fine, it's just buzzy. Let me turn up the audio while it's on pause. There's just a lot of noise here. Okay, the funny thing is, touching the cap, I still hear the radio station. It's like a guitar riff happening right now. Just for grins, just to see if this makes any difference at all, I'm going to swap out this capacitor. It's just weird when I touch it, I hear a radio station, and that makes no sense to me. I'm not really going to believe that this actually will make any appreciable difference, but I don't know. Let's just give it a try. All right, well, it's still buzzing, but touching the cap doesn't make any change. There's no radio station noise or any other noise being picked up by me touching it. So that's something. Let's hit start. All right. It's working. It's buzzy. It's very buzzy, the audio. While pushing the reset button, that's loud. But check it out, I can touch the cap on the top and the bottom, and there's no radio station noise. Okay. I think the way I've hooked up the video on this is pretty good. I mean, we have jail bars, but otherwise the video looks really good. I think the way of picking up the audio like I've done here is just not a good way to do it. And looking online, it seems to be the way everyone else does it as well. And they don't necessarily mention that it sounds horrible with a lot of buzzing in it. Nintendo audio always has a lot of buzzing on it, even the front loaders do, but it's a lot less bad than this. It is funny how this op-amp IC seems to have failed on the channel that's handling the audio though. It was working, it was kind of then going in and out. Is that something I did? I don't think so. Maybe that was something that was done to this previously when it was attempted to have been modded in the past. Okay, well, I thought I was done with this console. It's all back together. It's cleaned up. You know, I spent a little bit of time just getting all the screws back in, cleaning it all up. And now it's doing this. Yeah, I actually don't, I don't know what to think. So the audio, if we, well, kind of comes and goes, and if the game is still playing, like it's still actually playing, but we're losing video, we're losing sync, it's getting corrupted, the audio goes away. I mean, I hear the buzz kind of comes and goes. I can't believe this. I just can't believe this console. What is happening? What is happening? I've said it like a million times. Look, it does it even here with no cartridge installed. Come on. Okay, I need to take a break from this console. I'm gonna have to end this video here on that bombshell. I really, really thought this was a fully functional Famicom game console, which is why it's all back together. All the screws are in, and I cleaned it up. In fact, one thing I've really wanted to do the whole time I've been working on this is peel off the plastic off the Famicom badge, because it's been staring at me and kind of bothering me the whole time. Luckily, or hopefully this will peel off. I'm actually not sure if this is supposed to peel off, but this type of plastic, when it's been on there so long, it doesn't peel off very well, which is what's happening here. Okay, well, that looks better. It looks a lot better than it was, yep. Not sure if that was supposed to come off, but I'm glad it's off. If you recognize the symptoms of what this thing is doing just sitting there, let me know. I don't think it's the voltage regulator, because I can see the current draw on the bench power supply and it stays steady all the time, even when it's blipping on and off. So it's not like it's losing power and coming back, especially because if it was losing power, everything would reset and the game wouldn't kind of continue where it left off. It does kind of scream that it is the clock, because that would kind of get the CPU all messed up and then the sound stuff would stop working. And anyways, I don't know. And I don't really understand that, because Nintendos have been such reliable consoles for me. All of the ones I have just work really well. So I don't really get what's going on with this one. If you've been watching this and you see me making all sorts of mistakes when it comes to this console and you recognize those mistakes, definitely let me know in the comment section, because I don't really know why this console sort of keeps breaking on me. It just seems like it's a little bit cursed. Anyhow. If you've enjoyed this video up until this point, put a thumbs up if you don't mind, or thumbs down if you think this is all pretty terrible. I'm going to try to document the mod that I did for the composite mod in the description. So if you're here to just do a composite mod, you don't need to watch the whole video. Just look down the description. I'll just describe what I've done here on this little ASCII art thing. And, you know, subscribe, YouTube, usual junk, whatever. And huge thanks to my supporters. I'm feeling pretty defeated right now with this game console, and I'll have to come back to it because I really, really want this thing to work. At least it looks really good. Visually, this thing is stunning. Okay, that's going to be it for this video, so stay healthy, stay safe. I will see you next time. Bye-bye.